All right, so let's graph y is equal to 3 tangent of 2x. State the period, domain, and range. So do you guys remember that we had a formula to find the period for sine and cosine? Okay, and the way that you knew that the period was going to change, remember, is if there was a multiplier in front of the x. Same thing for tangent. So do you guys see how this 2 is in front of the x? So to find the new period, let's just use capital T like last time. Capital T is equal to, remember for sine and cosine, what was the formula? 2 pi over b. The reason why it was 2 pi was because the period of sine and cosine is 2 pi. But what's the period of tangent? Pi. So the formula now is going to be pi over b. I'm going to highlight that so you guys remember that. It just depends on the function you're dealing with. So since it's tangent, it's pi over b. So it's going to be pi over, what's our b value? 2. That's really the only big difference besides the asymptotes. That makes things kind of weird. But same thing as we did with sine and cosine. Now we find our scale. So last week, what do we divide our period by to find our scale? 4. So it's going to be pi over 2 divided by 4. Remember when you divide fractions, multiply by the reciprocal? So what is this going to be, guys? Pi over 8. Okay, is everyone cool with that? You guys don't look very happy with this. Okay, so same idea. Now what we're going to do is if we think about what the tangent function looks like, we can use that idea to graph the transformation. So for your test, I'm trying to help you guys out. Your test will be not next week, but the week after. When you guys are testing, you guys just need to know sine, cosine, tangent. But because you guys are in this class, you guys will also learn cotangent, cosecant, secant, but I'm not going to test you guys on those. Okay, those are just so you guys learn them. But looking at your notes from yesterday, what was the first value for the tangent table we used? Negative pi over 2. And then just like sine and cosine, we're going to go by pi over 2's. So if I add, oh no, just kidding. It's pi over 4, my bad. So it's negative pi over 4, 0, pi over 4, and then pi over 2. So if you do this correctly, for the tangent table, the first value and the last value of one cycle should be asymptotes. So I'm going to draw these little lines right here, like, because it can't happen. That doesn't exist. So we're going to just write asymptotes there. And if you guys watch the video, just like what we did for sine and cosine, we want nice numbers if we can, right? The tangent of negative 45 degrees is a very nice number. What was it? Negative 1. Tangent of 0 is 0. Tangent of pi over 4 is 1. Okay? All right, so here comes the weird part. And I'm recording this, so if you guys want to go back and watch it, like and subscribe. I'm almost at 100 subscribers, guys. I know, it's crazy.
Celebrate.
No, I might. Bless you. Okay. The period changed, right? So what does that mean about my table, guys? Are the x's going to change or the y's going to change? I heard different answers. The x's. Because if the period changes, that means your scale is going to change, your x scale, right? So your x's are going to be different. So this is what I want you guys to think about for tangent. And I'm trying to make this as easy as possible because I understand this is difficult. I remember when I was a senior taking pre-cal, I was stressed when this came up in the test. I was so stressed out. And I probably got it wrong, but it's okay. I survived. I'm here. But I'm not going to give you guys tangent problems where you're moving left and right. Only sine and cosine. So do you guys see how 0 is in the middle of this table? Since I'm not going to move left and right, it doesn't matter that my scale changed. I can still center my function at 0. 0 will still be in the middle, just the values around it are going to be different because my scale changed. So do you guys see how these are in the negative direction? What was my scale? Pi over 8. So what I'm going to do is I'm going to go backwards pi over 8 to get the other values. So this is going to be negative pi over 8. What would this be? Good. Negative pi over 4, which is 2 pi over 8. Yeah. Is everyone cool with that? If I go again, this would be negative 2 pi over 8. 2 over 8 is the same thing as 1/4. Okay? Now, if I go forward, it's going to be the same numbers, just positive. So it's going to be positive pi over 8 and positive pi over 4. And if you guys are confused, remember, we're using what to figure these out? Our x scale. That's why we found that, because our scale tells us how to jump in the table. Okay? Okay. Questions? Are we okay? Don't be shy, guys, because I know these are weird. No? You guys are lying. You're terrible liars. So let's think about this. What's here? What does that mean? Undefined. What's here? So guess what? Same thing. The first and last values should be undefined. Now, how am I going to get my other numbers? Well, what's our A value? 3. So I'm going to multiply what? X's or Y's? The Y's. Good. So multiply the Y's by 3. So it's going to give me negative 3, 0, 3. All right, I'm going to copy and paste my table so I don't have to scroll up and down and make you guys sick. All right. All right, so let's recall from Unit 6, how do we draw our asymptotes? Using what? Little dashes, right? So your asymptotes are at negative pi over 4 and positive pi over 4. And then let's just plot the other points. So we have -3, negative pi over 8, 0, 0, and then pi over 8, comma 3. Now, you guys, I want to say I say this in the video because I say this every time when I teach this. If I wasn't here to help you guys graph this and I want to connect these points, what type of function does this look like if I try to connect the points? It looks like a line, right? But is this going to be a line? It almost looks like a cubic function. It goes negative infinity, curves, goes through these points, and then curves, and it just gets closer and closer and closer to the asymptote, okay? So it's going to look something like this. Something like that. Hopefully prettier than that because it looks kind of ugly. Okay. Questions on the graph, because now we're going to do the fun part, because what did you still have to say? Domain and range. So the format. So listen, the format for the domain is always the same. So it's going to be all x where x cannot equal. Because these are vertical asymptotes, right? So that means that the function's undefined. What do both of these asymptotes have in common? They're both pi over what? 4. So that's what goes here. So it's going to be pi over 4. But there's this thing about, guys, are these the only asymptotes? So the next one's going to be where? Remember I said tangents are always odd. So this is 1 pi over 4, right? So the next one would be 3 pi over 4, and then? So it's going to be, what variable do I use? K. Where x cannot be k pi over 4, where k is odd. There is a much nicer mathematical way to write that, but I don't want to scare you guys. So I'm not going to show you guys it. What's the range? All real numbers, that's easy. Okay. Whew. That was fun. Questions? How are we feeling? Do we hate this? It's okay if you guys hate it. You guys are too kind.
Thank you.
All right. So write this down with me, guys. We can graph y is equal to the cotangent of x by remembering that cotangent of x, remember cotangent and tangents are, what's the relationship? They're reciprocal. So if tangent is y over x, that means cotangent is the same thing as x over y. What is x on the unit circle, cosine or sine? Cosine. So that's the same thing as cosine of x divided by the sine of x. And we can't divide by 0. So where the sine of x cannot equal 0. Because if it does equal 0, then bad things happen. So what I want you guys to think about is if we just imagine our unit circle, where is y equal to 0? Because remember, y is sine, right? Which 2 points is sine equal to 0? Up and down, left and right? Y equals 0. The left and right points, right? Because y is 0 right here and y is 0 right there. So this is the point 1 comma 0. This is the point negative 1 comma 0. So this is what I'm trying to point out to you guys. Why is 0 here and here? What angle is this on my unit circle? 0. What angle is over here? 180 or pi. Okay? So in other words, do we want x to be 0? Do we want it to be pi? No, because then if these are 0, can we divide by 0? So guess what else has asymptotes? Cotangent has asymptotes. But this one's actually not as bad because what do I add to 0 to get to pi? 0 plus what gives me pi? 180 or pi. Let's think in terms of radians, guys, so no more degrees. So pi. And then that means if I add another pi, do you guys agree that'd be 2 pi? Another asymptote. 3 pi, 4 pi, 5 pi, 6 pi. Every pi, there's an asymptote. So if I look back at my notes over here, do you guys see how we had to say k was odd? You don't have to say that for cotangent, and let me show you why. So let's draw a graph. So what I want you guys to do is I want you guys just to draw something that looks like this. So what do we know about this graph? Where is there going to be an asymptote according to my unit circle? At pi? And according to the picture, where else? Where? Pi and where else? Yes. No. Guys, what's in red on the circle? 0. Okay. So here comes the cool part. Tangent looks something like that, right? Between the asymptotes. Cotangent is the reciprocal. So instead of cotangent looking like this, cotangent is going to look like that. So instead of going bottom to top like this, it's going to start at 1, then 0, and then negative 1 between the asymptotes. So at pi over 4, we have 1, then 0, and then negative 1. And same idea, it's going to curve and look, if I can go through the points. Oh my goodness. This is embarrassing. There we go. So it looks something like that. And then same thing, it's going to do this every cycle, so it's going to go 1, 0, negative 1 on this side. So 1, 0, negative 1. So it looks something like that. Questions? Is this going to be on your test? No. And the reason why is because even in calc, guys, this is my first year teaching it. Cotangent graphs never really get talked about in calc. Tangent graphs do. Sine and cosine graphs do. Like in calc, you won't be asked like to graph a function, but by remembering things about the graph will help us solve some problems. All right. So what I want you guys to understand is we have asymptotes for y equals cotangent of x at x equals 0. Then do you guys see how we have an asymptote at negative pi and at positive pi? So does it make sense I could write it like this, plus or minus pi? Is everyone cool with that? No? Yes? Okay. Are we alive? If I'm following this pattern, guys, do you guys agree this distance from here to here is pi? Where would the next asymptote be then? 2 pi. So plus or minus 2 pi, plus or minus 3 pi, and so on. What do all these numbers have in common? What are positive or negative whole numbers called? Integers. So that's how we're going to say the domain. So the domain for tangent, or cotangent, excuse me, is all x such that x cannot be equal to k pi, where k is any integer. We can't say number because you guys agree like fractions are numbers. Decimals are numbers. Pi is a number. In this case, it has to be an integer. 0 is an integer, technically. And then what's the range? Still all real numbers. Hooray. Okay. All right, so let's just put this information in the box. Cotangent is odd. I mean, it is a little weird, right? So it makes sense it's odd. Bad joke, bad joke, bad joke. What's the period? Pi. X-intercepts. What do all these have in common? Negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2. What are all those values? Odd. And what else do they have in common? They all have pi over 2s. So we can say odd multiples of pi over 2. Vertical asymptotes will occur at x equals k pi, where k is an integer. Questions, comments, complaints, concerns, worries, frustrations, disappointments, highlights. Okay. Let's do one more example and then we'll see where we're at. Okay, so in the video yesterday, I had mentioned that for these graphs, what's the range? All real numbers. So you guys don't have to find your amplitude because amplitude's irrelevant. Because amplitude for sine and cosine tells you like the highest point and lowest point. But since it's all real numbers, it's going to go up forever and down forever. Does that make sense? So there is no amplitude, so we don't care. So we can just jump straight to finding the period. Is the period going to change? Yes, because there's a multiplier in front of the x. So the period, so capital T, is going to be equal to, what's the period of cotangent? Pi over b. So in this case, it's just going to be pi over 3. Okay. Since the period changed, that means I also need to find my x scale. So the formula is t divided by 4. So it's going to be pi over 3 divided by 4. Okay, don't be sloppy when you guys do this, guys, because I caught you guys when you guys did the last problem. Don't forget your fraction rules. If I'm dividing this by 4, I need to remember my dividing by fraction rules. So I need to multiply this by what? The reciprocal. What's the reciprocal of 4? 1/4. So it's going to be pi over 3 times 1/4, which is pi over 12. So that means every tick mark on our graph is going to be worth pi over 12. Okay? All right. So same idea, let's make a table. So y is equal to cotangent of x. Cotangent's nice because it starts at 0 and ends at pi. And then the values in between, I'm going to pick pi over 4, pi over 2, and 3 pi over 4. So everything is connected, guys. So if you guys are confused, like, why am I going by pi over 4? What's the period normally of this? Pi. To find any x scale, what do you do with your period? Divided by 4. So what's pi divided by 4? Pi over 4. What am I going by? Pi over 4. So that's the same idea. Okay. What do we know is at the endpoints in my table? Asymptote. So there's an asymptote here and an asymptote here. And then what I try to show you guys is cotangent does something like this. So what number am I going to put here? 1, 0, and then -1. Okay, so you guys just practice one together, but let's make sure you guys are okay. I'm not going to give you guys problems that shift left and right. So do you guys see how this one started at 0? That means that this one's also going to begin at 0. The only thing that's going to change is we were jumping by pi over 4s. What are we jumping by over here now? Pi over 12. So this first value is going to be pi over 12. If I add another pi over 12, that would be 2 over 12, which is the same thing as pi over 6. Okay, so hopefully that makes sense. 1, 2, this would be 3. What's 3 over 12 the same as? Pi over 4. Okay, this one's interesting because they all reduce. 1, 2, 3, so this one's 4 over 12, which is pi over 3. And can I stop? Yes, because what was my period? Pi over 3. Okay? So if I'm following my pattern, if I did this correctly, that means that this point and this point should also have asymptotes. according to my equation, do I need to multiply my y's by anything?
Yes.
Yes. What? 2. So if I multiply all my y's by 2, I'm going to get 2, 0, -2. All right. So let's go ahead and graph this. Okay, so if I plot my points, it should look something like this. Should it be a straight line? Should it be a straight line? No, it should be, almost looks like a cubic function, so it looks something like that. Okay, well, that was fun. What is my domain gonna be? Where are my asymptotes happening at every what? Every pi over 3. Okay, so what, how am I gonna write that? The domain's gonna be all x such that x cannot equal k pi over 3. What's my disclaimer for cotangent, where k has to be what? An integer. K is any integer. And then what's my range? All real numbers. Okay.